when you are adding and subtracting radicals, you kind of do it the same way. Don't write this down unless you want to in your notes, okay? 3x plus 2x. What's 3x plus 2x? 5x, okay? Because these are called like terms, right? So you can only combine, like terms in radicals, you can only add together radicals that are the same. So if you have like 3 root of 5 plus 4 root of 5, how many roots of 5 is that altogether? How many roots of 5 is that? 7 roots of 5. And that's pretty much what it comes down to. What you can't do, you can't take like 2 root of 3 plus 5 root of 6 and add those things together, because those are not like terms, okay? So you can only add radicals, can't. You can only add radicals if the thing under the square root thing is the same. But there's a way to change it so that they are the same, so then you could add them, okay? So can't do. So let's try this one. Good, tough one. 4 root of 3 plus 7 root of 3. Try on your whiteboard. A toughie. Yay. Everyone's got to participate. Yes, Charlie. Yes, Tate. David, you can put your phone away. You don't need your phone for this, okay? Oh! Holy cow, I got to point something out here. Everyone look at Jessica's board.
Whoa.
This is Jessica.
Oh my gosh.
It's crazy.
Jessica made a mistake. Oh my God.
7 plus 3.
Oh my God.
I know, I saw the crazy.
She had it wrong. Okay, so that's I don't need to big just first time for everything, right? Okay. So it works with fourth roots too. So if I were to have you try this one, 7 cube root of 4 plus minus 5 cube root of 4. What do you get? Go ahead. Write it down, David, or I'm going to give you 5 points. Okay? Write something down. Okay? That is correct. That is correct. See, Mandy, you have missed a step. Very good. Very good. Back there, Kaylee, Charlie, what do you got? David, that's correct. That's correct, Andres. Let me see your thing. No, you do not add these together, you just leave it. What does that say inside the bracket there, Ian? 4, right? So you just subtract the coefficients, right? So 7 cube roots of 4 minus 5 cube roots of 4 is 2 cube roots of 4, right? You don't have to change anything inside the bracket, okay? Let's try one that can be a little bit, it's a little different. What if I had 5 root of 7 minus 8 root of 11 plus root of 7 plus 9 root of 11. So remember, you can only add together, you can only add together the like terms. What am I looking for? So yes, so if I combine the like terms, I get 6 root of 7 plus root of 11. Good thing I didn't get that while I was recording. Okay, so moving on, that's easy, right? If I have something that looks like this, okay, which you will, and this is where 2 root of 5, 2 root of 5 plus 3x root of 5, okay? You still have a root of 5, and these are still like terms, but you only add together the coefficients. Charlie, pay attention, okay? So this is 2 plus 3x in parentheses root of 5. You have to put the 2 plus 3x in parentheses. Otherwise, it's 2 plus 3x root of 5. This is not the same as this. Okay? No, it's not 5x. You can't combine these. You're done at this point. Okay? You're done at this point. Okay? Because you just add together this and this, which can't really be added together, so you put it in parentheses and then you multiply. You don't do this because you have to put the parentheses in there. Okay? So let's see if you guys can simplify this one. Simplify. You try to simplify 4y root of 3 plus 6 root of 3 plus 2 root of 3. So use the idea that I did here and see what you come up with. Where's my... So you should have gotten 4y plus 8 in parentheses square root of 3. Very good. So you guys almost have this mastered. Okay, so then this is the fun part. You're going to love this, okay? Say I had something like this, square root of 50 plus square root of 8, okay? Can you add together the square root of 50 and the square root of 8? No, because they're not really like, they don't have the same thing underneath the radicals. But you can simplify these, okay? So for those of you who aren't here, how do I simplify square root of 50? What perfect square is in the square root of 50? There's a 25 in there, right? And 25 times what? 2, right? So that's equal to the square root of 25 times square root of 2. Basically, I'm just really factoring, where I'm trying to pull out factors that are perfect squares. How can I break up square root of 8? What perfect square is in 8? 4 times what? 2. So that's square root of 4, also times square root of 2. What can I pull outside of this box? I can pull out a 5. 5 square root of 2. What can I pull out of this box? 2 root of 2. Hey, it's the math here. 2 root of, oh, sorry. Okay, so what's 5 root of 2 plus 2 root of 2? How many root of 2's do I have? 7 root of 2. 7 root of 2. Go, math, go. All right. So, do you get that? So they won't always simplify it like that, but a lot of times you have the same thing in the radical that's being hidden. Okay, so I'm going to let you guys try. Oh! Gesundheit. God bless you. You try. You need Kleenex. Okay, here we go. You try square root of 125. Square root of 125 plus the square root of 80. Okay? Try that one. So this most of you got 25 times 5, right? I did give you a little hint, and I told you this is 16 times root of 5, and so that becomes 5 root of 5 plus 4 root of 5, which is equal to 9 root of 5. Now, just in case you mess this up, you said, well, I know that the square root of 80, I can pull out, that's 4 times 20, right? Also, and you said, oh, 4 is a perfect square. I could pull that outside, right? So I said that's 2 times the root of 20. But what perfect square is in root of 20? What perfect square is in 20? 4. So if I pull down another 4, see, and that becomes 4 root of 5, and the square root of 4 is 2, I still have this 2 up here, which is 2 times the root of 5, which ends up being 4 root of 5. It's a lot longer process, but if you didn't pull out that 16 times 5 at first, you could have done it in 2 steps. First pull out a 4, then pull out a 4 out of the 20, and then multiply this 2 times that, 2 times the root of 5, and you still would have got 4 root of 5 for the, you understand what I mean there? Okay? So, you ready to do more? You ready to do more? I think you could do that one. I'm not going to try. Just to show you, if you end up with something like this, this is a tricky one, okay? 3, let's change colors, because it's time. Is it time to change colors? It is. What's this? Where's my tools? Oh, there they are. Let's change colors to this color. So, if I had something like 3 cube roots of 16 plus 2 cube roots of 54, it works the same way, okay? You can put, what perfect cube is in 16? Not 4, a cube. 8, right? 8 times a cube root of 2, right? Because 2 times 2 times 2 gives you 8. What perfect cube is in 54? This is a little trickier. What times what? There is a perfect cube. Perfect cubes are 8, 27. What's next? 4, 64. What's that? 5 times 125. Those are perfect cubes. These are x cubes. What perfect cube is inside of 54? 20. There's 2 27s in there. So I could write that as a cube root of 27 times the cube root of 2. Cube root of 2. And then I could pull out, what's the cube root of 8? 2. So I have 3 times 2 times the root of 2 plus 2, what's the cube root of 27? 3, 2 times 3 times the cube root of 2, right? Which gives me 3 times 2, which is 6, whoops, 6 cube root of 2 plus another 6 cube root of 2. How many cube roots of 2 do I have altogether? 12 cube roots of 2, okay? So that's, look, we're almost done already, okay? So, let's try one, okay? You try. Who tried? You try. You try. You try this. This. You try. 4 root 27, notes, these are just square roots. 4 root 27 minus 3 root of 12. The only thing that's different from that last one is these ones is that, whoops, sorry, I keep doing that. Not that, not that, I'm trying to pause. So you get 4 times 3 times root of 3 minus 3 times 2 times root of 3, which is 12 root of 3, minus 6 root of 3, which is equal to 6 root of 3. Too bad we don't have a math here for root of 3. What's wrong, Chase? No, you can't just add them. What? What do you mean add what? At the very beginning? 7 and 8. That's just coincidence. That's just coincidence. Yeah, it doesn't work out. So now we're going to do the root of 3 cheer. Root of 3, 3. Root of 3, 3. Who thinks they can do math better than me? No, I don't know. I just made that. Okay. So we'll try to come up with a new math. Where we go? We need a new page. It's a beautiful sunny day. Okay, one more thing, and then we'll kind of be done. If you have something that looks, which you will, unfortunately, sometimes they have things where everything, you've seen ones like this. Ooh, this is a hard one. Where everything cannot be pulled outside of the box, okay? So minus cube root, well, we already kind of saw one like this. So 48x in here, okay? So if I have a cube root, I have to look for perfect cubes inside. Does 6 have any perfect cubes in it? No. Okay? Does x to the 4th have any perfect cubes in it? What is a perfect cube of x to the 4th? What perfect cube is in x to the 4th? X to the 3rd. Okay? So what I want to look for is perfect cubes inside the box. So this one over here can be rewritten. I'm going to leave the 6 in the box because it can't come out. Okay? I'm going to take an x cubed and leave that inside the box, but I also have to have a cube root of x. Do you guys understand why that is? Because x cubed times x gives you x to the 4th, right? And this has to stay inside the box. Minus, there is a perfect cube in 48. Who knows what perfect cube is in 48? 8, right? 8 times what gives you 48? 8 times what gives you 48? 6. The root of x, the cube root of x, I cannot pull outside of the box. So I'm going to leave this here. I'm going to pull out an x out of this box, right? Because this could come outside because it's the cube root of x cubed, which is just x. Then inside the box, inside the cube root, I have a 6 and an x. Minus, what's the cube root of 8? 2. And then I have inside the box a 6 and an x. So altogether, I have this minus this cube root of 6x, which you have to put in parentheses. X minus 2 cube root of 6x. That's a tricky one. Right? Oh, there's one more that we have to do. Don't forget your parentheses. Am I not done yet? We're gonna, so just so you know, that's another tricky one you're going to see. What if I see something like this? This one isn't as bad, which you will, because I know I looked at your Math Excel and like the last 4 or 5 problems. There's only 11 problems on the Math Excel, and these last few are kind of like this. And if I don't teach you this stuff, you're not going to know what to do. Okay? Plus square root of a minus 1. This is an example. Anyone see something I could do in there? What's in both 4a and a 4? What's in both 4a and a 4? There's a 4, right? So you said 2, but I think you meant the square root of 4, which is 2. So I could pull out a 4 like this, a minus 1. I would write this one down, okay? Square root of a minus 1. What perfect square can I bring outside of the box? What's the square root of 4? 2. So I have a 2 times the square root of a minus 1 plus the square root of a minus 1. How many square roots of a minus 1 do I have altogether? What's 2 plus 1? 3 square roots of a minus 1. Okay? So I'm going to give you a similar problem to this one to try, and then we'll be done. All right, we have 8. We have a few minutes, okay? So try this one. You try. You try. Okay? Square root of 9y plus 27 plus 5 times the square root of y plus 3. Okay? And so you could pull out a 9 out of here, right? Square root of 9 times y plus 3, right? And then plus 5 times the square root of y plus 3. You can pull out 3 outside of the box now. 3 plus y plus 3 plus 5 times the square root of y plus 3, which altogether gives you 8 times the square root of y plus 3. Udabong. Okay? Very good. So that was very good. I think you guys learned something.